Okay, so welcome to the Rust Maven meeting. It's part of the Code Maven series. My name is Gabor Sabo. I teach Rust, I teach Python, I help companies introduce testing. And while I'll teach, and I also organize events like this. And my feeling is that one of the best things we can do as programmers is to share information among us, to discuss things, and to provide a platform for people to show their projects. So, with this said, actually, people who are watching the video, yeah, please make sure that you like the video and then follow the channel. I keep forgetting to say this. If you are recording this, and people who are participating in it, you have the option to actually ask questions in the chat. If you have any issues with the sound or something, just write in the chat. I'll try to deal with or help dealing with things. Okay. And now, thank you, Ohad, for joining us. And the stage is yours. Please introduce yourself. Tell us about your project and so on. Okay.
Hi, thank you. So I'm Ohad. I'm working on a project called BlockMesh Network. So we started as a decentralized network for scraping. So basically, if you're familiar with the data scraping through proxies, right? This is what we started at, as a network of individual nodes that people can run them, and then the network uses them as proxies. We have expanded our use case slightly to also collect data feeds of users from like multiple users and get their kind of perspective of the internet and specific feeds. And then when you cross correlate that, you can actually detect, trends and signals for financial use cases, for social use cases, and so on. It started as a hackathon project, right? So there was a hackathon that I joined, took first prize at one of the tracks there. And then the hackathon organizers, they also have like an accelerator program. So they offered me to join, and I did. I got like a small funding check from them and continued to work on it since. Um, the use cases for it, one is public data scraping. If you're familiar with, Bright Data, Oxy Labs, and so on. So this is what we started, and now we're, like I mentioned, like expanding to new capabilities that have more of a kind of like sentiment analysis.
Ohad, I would like to stop you for a second because I don't know these tools. And you mentioned data scraping, but I don't know. I'm not sure I know what that means. I know what web scraping is.
Yeah, that's the same thing,
So
right? Like you
looking at
scrape.
websites, basically.
Yeah, and in order to scrape, website and specifically public data at scale, you need to use multiple IPs, right? Or if you want, you'll be get blocked. You'll basically be detected as a scraper, as a bot, and so on. So you'll be easily blocked. You can't really use data centers. You need to use residential IPs. Basically, you need to use individuals that will provide their resource, their computer, for you to use as a proxy node. That way, when you distribute your load, right, of scraping through thousands or even millions of users through different IPs, different profiles, and so on, the target site does not detect you because they see organic or sort of organic looking traffic, right? But inside of the organic traffic is actually some of it is actually your scraping, architecture that actually uh, takes
Okay.
data in an automatic fashion. And let's talk on the Rust side of it, right? Because this is why we're here. So just my background with Rust. So I actually heard about Rust around 5 years ago, I think, so long time like that. The main memory that I have of like really starting to notice Rust is when I heard the maintainer of Active Record which is like the main SQL ORM on Ruby on Rails. Which I used to do like a lot of Ruby on Rails. So the main maintainer there moved to Rust. He actually wrote Diesel. If you guys are familiar with it, it's one of the main ORMs on Rust too. Um, and that kind of made me think like, oh, like if this guy is moving, and there were a lot of other like prominent people, and it was very interesting because Ruby and Rust are kind of like complete opposites, right? Like Ruby is very dynamic, like do whatever you want, while Rust is very strict. And I started playing around with Rust ever since, and really like it started to get more serious about 3 years ago when a few friends of mine kind of told me about like a Solana, it's a specific blockchain, and I was like, I wasn't into blockchain prior, but when they kind of talked to me about it, it was interesting. And one of the main things that actually got me into it was that actually it's also like written in Rust. So I was like, oh, like I have something to do more with Rust, which I wanted, and I went deeper, and ever since I'm going more and more. And basically today I do only Rust, and and BlockMesh Network is written completely, basically like 99% in Rust, and it's everything. And I'll go over the list because there's a lot of variations and like stuff that people don't really understand that you can do with Rust. So obviously, we have command lines, right? That is very common. We have web servers. That's now it's common, like it wasn't that common a few years ago, but with Axiom and Actix, it became way more easier to build web servers with Rust. But the more exotic stuff is the front end is also Rust. I'm using Leptos. It's a very interesting framework. It uses it doesn't work, for example, like React. I think it's more similar to Solid. So it's all these functions that kind of like automatically get updated. It's a little bit tricky to write it properly, but it's really interesting. And the guy that wrote it is like a really nice guy that has like great tutorials. So I highly recommend it. You basically write in Rust, it compiles to WebAssembly, and then it's loaded into your front end and works just like any other, web app that you're familiar with. I actually did a little bit of mobile development in Rust too. That was very tricky. I basically built like a shared object and integrated it via FFI. So basically, I have like a React Native application that wraps up and just do, FFI calls to a shared object. And the obvious question is kind of like why I'm doing all these kind of weird stuff. And it's actually because you can't really do it if you think about it like with other stuff. Um, I basically have like one monorepo. All the code is in it. Everything compiles it and it's in sync, right? And I don't need to kind of redo code, right? Because everything is in Rust, so I can just import from a different crate in the same monorepo across basically everything, front end, back end, whatever. There's always like all the types, all everything is in sync, very easy to use in that regard. There's no maintenance of multiple different languages and different APIs. You need to keep syncing them and so on. And this is also one of the reasons that I actually, in general, I really like Rust. Like the tooling is very good, right? Like we all know Cargo is amazing. The monorepo in Rust, I think it's the best I've ever seen. Like it's highly recommended if you have anything that's complex, using a monorepo in Rust, like a workspace, works great. Like it's like a first class citizen. It really makes your life easier. You don't need to keep syncing multiple repos and dependencies and so on. It just all runs perfectly fine. And obviously, we all know like all the benefits of Rust, like it's very safe. For example, because of the lack of resources that I have, I don't write that many tests, like basically almost no tests, but I'm still able to work at very high capacity with very low errors because of how Rust works. Like if you make sure that you handle your errors and don't just unwrap and all of that, you can get to a very high confidence in your code even without testing. Just handle, the errors, right? Like because that's the beauty of errors as values. Like you know when they happen, and if you don't ignore them, you will probably get like a properly working program, even without having some very very thorough test coverage. Um, what else? So basically, we have and other things that we have like that we also built in Rust, a Chrome extension, also written in Rust. Um, Again, basically everything that we do it with it. It just makes our life way easier because it's all in the same language. Everything is synced, and we just like it. And again, like even if we need to do something which is blockchain oriented, like I mentioned previously, like Solana is also written in Rust, so that helps us make everything very very smoothly instead of doing the serialization, deserialization, and so on. This is was the main motivation for us, and also performance-wise, like we're able to maintain. I mean, we have servers running thousands of requests per second, running on hosts that cost a few bucks per month, basically. Like
So
run,
tell me. Sorry that I got into in the middle. So this is an open source project, right?
yeah.
Uh, and do you do you get finance to work on this, or do you do it in your spare time? Do you actually make money out of this, or how does it work? Is there a company behind it somehow?
Yeah. So as I mentioned, right, so it started as like a hackathon project.
Yes.
We got small funding. So now there is a company that maintains it, which I'm running it. We are working on expanding it and getting more funding. At the moment, it's still, not profitable. We're mainly aiming to increase size and the product. We now currently have over 500,000 clients installed. Most of them are web extensions, but we have also like CLIs and a mobile version that now they're kind of like on ice because we're doing a rewrite. Um, sorry, but we have, it's a pretty large scale because you have hundreds of thousands of clients, and they need obviously to all kind of talk to a server that needs to actually manage them and tell them what to do and interact with them and so on. For example, we hold at any given moment close to 250,000 of open WebSockets, like existing WebSockets to these clients that we basically manage them remotely via that WebSockets.
So I'm trying to understand that. What you're saying is that you have, if I understand correctly, agents installed on home computers of people, and then
Yeah,
you can run scraping process. Let's say you want to download, I don't know, 10,000 pages from some website. They go out to these agents and download these pages, right?
roughly, yeah.
Okay. Uh, those people who install the agents, why do they install it, and is there anyone who's paying to? I mean, if I want to now, let's say I would like to go ahead and scrape some website, okay? How can I use your is it your system, your clients, or how do I connect to these all these machines?
Yeah.
Or I
So,
need to get people install agents for me?
no, no. So at the moment, we were still not offering, some open API and not even a paid one because we're still working on it. We have a few partners that we work with them, on a private fashion. We provide them data and so on, but it's not yet, open to just anyone that can just register and use it. That's hopefully in the future, but at the moment it's still a work in progress. We are working with these clients to collect data and process that. I mean, we just released, for example, like a day or two ago, a data set of tweets, right? Like around 30 million tweets from Twitter that we scraped. If you're familiar with what's going on Twitter today, like since Elon came in, it's very hard to extract any kind of data, especially at scale from Twitter. So collecting, 30 million of them over a couple of weeks is actually pretty good. And this is just the start. We think we'll probably be able to hit a few X's of that.
Okay, but so you're collecting data for yourself, right? That's what you're saying?
Um, it's not, I mean, it's not like for myself. I mean, we are working, for example, we do now with an AI agent that uses that data to train the
Mhm.
agent, and we're working on partnerships with people that will actually take that data, analyze it, generate signals, for example, for trading, right, and so on.
Okay, so I have like two directions. First of all, if anyone from the audience would like to ask question, please just type in the chat, and I'll and you get some answer from Ohad, I guess. I'll read it out, or Ohad will see it. So just feel free to ask questions. I have like two directions I would like to ask you. One of them is okay. How can if so what can I do now with the project basically? If I would like to start doing something, and then another thing would be to actually look at the code, or and maybe these two are somehow combined. I don't know. To look at the code, look at the repository, and to see a little bit, to understand a little bit of the code basically.
Sure. So as I mentioned, like for you to use as a data consumer, currently that's not available yet, right? I mean, if you want to consume the data, you need to basically talk to us and we'll be able to provide it to you, but not for some, API that you can just come in and register and so on. That
But
that
can
is
I can
not.
I just set up my own network? Ask three people, let's say, just to be small, to install the agent, and then
Technically, yes. I mean, and for example, it will be probably easier on the CLI, but you can also on the extension. So technically, you can just take the same code and all of that and just deploy your own versions, just change, the URLs of the server that it uh, connects to and so on, and it will work, right? So that will work too. Um, I see the question. So how do we get the user to install? So basically, the user are incentivized by a future token that we will issue, right? And basically, revenues of they basically um, will get a share of a future token that we will issue, and they are running the nodes for that, right?
Mhm.
Also, what are the applications of the script data? So as we mentioned, one of them is to train AI agents. That's actually being used now. The other big thing is that we see is financial signals. I mean, we know that Twitter is like where all the action is, especially like trending stuff, especially for crypto. All kind of like all the trends start there. And I'll say another question. And basically, if you're able to collect data at scale and from different perspective, you're able to cross-correlate it and extract that and find, what is an emerging trend before it's too late, right? This is like the main thing that we're working on it now. You mentioned if you scrape too much data, you will be banned. Also, the agent that, let's say, install it, accept the risk. Okay, so in terms of be banned, one of the reasons that you have like a lot of nodes is for you to actually spread the load, right? You don't want, sorry, you don't want to send a lot of requests through the same node. Sorry, just like Redek here said in the chat, because you don't want them to be flagged as a bot, right? Or some scraping node. So you manage the load to have like a relatively small amount of requests for each node, but you separate it to a lot of them. That way, it doesn't look suspicious in terms of like the activity. It's not like you suddenly send, 50,000 requests in a few seconds for some specific node, and then it will obviously be flagged. So you just take that 50,000 requests, spread them on 5,000 clients, each one of them get 10, spread them over a few seconds, and then, it's basically like a very, very low level of intensity of each one of them, and it doesn't get detected.
Interesting.
Also, like another, maybe people will find it interesting. I'm also using Cloudflare a lot. And if you guys are familiar with, they have like, Cloudflare workers and pages. So I'm using that also in Rust. So like various workers, like if I want to do, some, I don't know, some page that I don't want to, run like a server for it and so on, you can just run even an HTML, right? Or on Cloudflare with Rust.
Cloudflow, it's called. I don't know.
Cloudflare. Like the you Cloudflare.
If you can type it in the chat because I'm not sure I got. Okay.
They're like one of
Okay.
the biggest providers, right? Like so they have like a very good support for Rust stuff. Um, so also highly recommended. Um, I'm using like a lot of. I'm also using, for example, forgot the name, Ascama, I think. It's like a template language. It's kind of based on Python Ninja or something like that. Forget the template in name. So it's very easy to create, um, basically again like it's full stack Rust. A lot of people are against it, I know. Like in the WhatsApp group that we have, right? People are kind of every time that I mention it, they think that like full stack Rust is like this taboo. But I actually think otherwise. Like if you actually give it a try, I highly recommend it. It's a little bit annoying at the start to get things kind of set up and working properly, but after it does, it's great. I
It
mean,
would be really nice if you could show us some code or these things of setting up things or I mean
oh,
if you're comfortable with,
setup is a
showing your
pain, but let
desktop.
me try and show you something. Let's see. Let me look up something here.
If you don't have anything on your desktop that you don't want to share.
Yeah, I'm just 1 second. Let's share this. Okay. So this is my mono repo. As you can see here in the libs, there's like a bunch of them, right? This is kind of the beauty of it, that you can basically do anything with it. And I'll show a couple of small examples so I just mentioned, right, like so doing like a web page with Rust, so with the Cloudflare worker. So this is it. So this is like our landing page. This is like a Cloudflare worker. There's a bit of some setup here. It's kind of like basically a template that you do. You basically set up a router. You can have like various routes, and each route you have like whatever the way you want it to respond. This is just some A/B testing, but basically then We call this struct, and this struct is it goes basically to this template file, and this is an HTML file with the template in language. You see here the includes. Very similar again. I think it's very similar to Ruby ERB and to I think Jinga, Ninja. Forgot the name of it in Python. But basically, again, very simple to use.
It's called Jinja.
Yeah, Jinga, something like that, right? And it's all again, and one of the beauty of it, again, it's all statically typed. Like if you have, for example, right, like if you have some variable that you forgot, where's the variables here? I think in this one I don't have any variables. It will detect it, right? So you won't have some missing element in the template or anything like that. It will check in compile time that all of these are properly defined, right? And they're actually inside of the template and all of that. And this is like, again, like for me, this is like the value of it, that I can run something and I know that like if it compiled, I'm like 99% safe already, right? I'll show a few more examples of interesting stuff that we have here. I'll show you some Leptos code because that's probably some of the stuff that people are less familiar with. So Leptos, as mentioned, it's a front-end framework. Again, so all of this, right? It's kind of similar here to React, right? So you have like a context, we have routes, and a route points to whatever other component, right? And again, and these components we see, so we have this macro of component, which implements an into view. This is something from Leptos. And you can see all of this, right? So these are all like very, very similar to React or in Solid and all that. And we have these signals. So a signal is basically a function that you can later basically call it inside of the view. And here, this is actually the generating of the HTML. And all of this, again, like it's all statically compiled, checked. You get very little surprises, right? So usually a couple of tests locally cover kind of like everything you need. You can see that, for example, here you see all these move. So basically, because of how it works, you need to have everything in these functions. That way, it's able to evaluate them and make it all responsive and dynamic with very little effort. There's no use effect like in like in React. You don't need to tell it what it actually depends on. It automatically detects it. What more is interesting here that we can show? Let me think. So the mobile stuff, right? Like I mentioned, it was a real pain to set it up. But after I did, at the end, it's basically just again like it's just a compiled Rust code that I called it through an FFI. And where is it? I'll show you the FFI stuff.
What was difficult to set up? Something.
It mainly just setting up of the FFI with Rust for just to have all the setup initially. Very little documentation in general, and especially with Rust on that. So for example, this is the wrappers for the Android version. So you see, for example, sorry, the naming convention, it need to be this weird stuff because of how, again, because of the integration with Android. So it needs to be like this Java, Expo, blah, blah, blah. But technically, like this is all just wrapping, and this is actually the actual code, right? So this code runs, the same code runs in Android, in regular CLI, in iOS and so on. They're all just wrapped slightly different, and this is kind of the beauty of it. And for example, I have like this crate, which is like a common crate.
So wait a second. Okay, just the iOS and Android, right? And command line. Are these all the agents or some kind of clients that can do something
Yeah,
else?
there are type of clients that they're nodes, right? They basically run, they connect through a WebSocket to the server, and then the server will basically instruct them what to do.
Oh, okay.
And we have multiple implementation in order to offer people, use whatever you want, right? And like I mentioned, because we use Rust for everything, and this monorepo, it makes it basically write once, use everywhere. That's kind of like how it works.
That was the
And
big dream also with JavaScript 10
yeah,
years ago, right?
JavaScript doesn't work. JavaScript just doesn't work in general. It doesn't work in anything. That's the problem with JavaScript. It never works.
Okay.
Um, for example, I have this common crate, and basically I just extract a lot of stuff to various common crates that I have. For example, various interfaces, like for example, the web server interfaces and a few others. I don't have the types actually inside of the server, because if I want, for example, to use it in some in the CLI, right? Then if it will be inside the server, I won't be able to import them. So I basically have the interfaces in a separate crate, and everybody just import the interfaces from them. And then all I need to do is just, define it there, compile it. It all compiles together and across the entire workspace, the entire monorepo, and I know that everything is aligned, right? So because they're all basically compiled together. So if there's any mistake anywhere, it will be triggered across the entire monorepo. That to me like is kind of like
Mhm.
close to magic. um,
Do you have anyone has anyone contributed to the project who's not like part of the project? So
there were a few minor stuff. I don't really have like open issues, and um, it's not yet, like not a lot, like not nothing significant that someone that's not really part of.
so the issues are not in the same repo or you just don't have so or what do
No,
you
so at the moment I don't have the issues there, mainly because I don't want to manage two systems of kind of like work plan and GitHub issues, right? Uh,
Mhm.
and so at the moment, I prefer to just have our whatever work plan we have in our Jira, and work, internally on that, instead of having this, both external and internal issues.
Okay.
I believe that once, it will be more people will contribute, it will make more sense to move some of it. But at the moment, because it's basically all internal, there's no reason to maintain, two issues systems.
Right, but are there areas that you think that people could contribute already?
Um, yeah, there's actually something that it's not it's at the moment it's private. I'll probably move it to public in the next few days. I'm working on another version of a Twitter scraper. It's actually a port of an existing scraper that's was written in Go, and it also has like a Node version, and there's no Rust version of it. So I'm basically migrating it to Rust. So
Mm.
if someone is interested in that, let me know. There's like plenty of work there to be done. Let me look for other interesting things. Also, like minor stuff that people are probably aware. So, for example, all of my libraries are all, workspace through in terms of versions. And by doing that, I only have the version actually specified in the root toml. And this ensures that everything is synced, that I won't have this annoying issue that I don't know, accidentally had like two different versions across my monorepo, and then suddenly there's like a dependency issue and so on. So everything is defined at the root, and everybody else just inherits the version from it.
But does that mean that every project compiles into it everything?
No, it means that when you have like workspace true, it says that I will take the version from the workspace. I won't specify, because technically you can specify different versions in it, and you can have like two
Okay. Yeah.
different crates that would, each one of them will use a different version, as long as they don't have any common code that will compile together. Technically you can have two completely separate dependencies. But that is kind of like a recipe for disaster, right? That kind of beats the whole purpose of having like a monorepo and a workspace.
Hmm.
Um,
Well, as far as I understand, Rust actually can handle easily or whatever, having multiple versions of the same crate in your project. Actually, you probably have, because two of your dependencies might both depend on something, and they might both bring in different versions of that common something that you are not depending directly, maybe.
yeah, but I'm trying to reduce the potential of issues, right? Because
Right.
uh, not all, I mean, that will work as long as there's no issues with the dependencies, right? But once these dependencies that you have do not work together, if Rust won't be able to overcome it. Like there's no magic in it. If you have like one crate that says I need version 1 and the other is version 2, if you try to compile them together, it will blow up, right?
Okay.
Uh, so I don't know. For me, it took a while to get the setup kind of working and everything, but now it works. There's like also like small things that I found out working on this complex setup is, for example, I have multiple targets that I'm actually compiling to. So you see, for example, pre-push and all of this, because I have a lot of different targets. Because, for example, when I compile to WebAssembly, it uses a different target. When you compile the backend, it compiles to a different target. Uh, there's a lot of dependency, cache invalidation that happens. So I had to play around with it and make sure
Mhm.
that I'm compiling to a different directory. Because before doing that, I kept having like very long compilation times because the caches kept be getting validated, and that was
Mhm.
just a real pain. Uh, so my target directory is like 100 gigabytes or something like that. It's crazy,
Okay.
but that's a small price to pay. Um, just a
So,
few more notes, like stuff that I think it's cool. Like some of the stuff that we have here, for example, when we started initially, like with the I basically wrote like a proxy, a pretty low level proxy with Hyper that really kind of connects, two TCP connections, that really connects them directly. Um, and again, like to me, this is again the beauty of Rust, that you can see in this repo that you have anything from FFI, low level, TCP handling, up to a Cloudflare page with a bit of templates and a tiny bit of Rust in it that doesn't actually do much. There's actually all of that can be done. Um, I don't know. I like it.
okay.
Um, let me see if there's anything interesting. Are there any questions?
You mentioned that you don't have a lot of tests, but do you have CI configured running the few tests, and maybe so like compiling and so.
Yeah, so I have a CI and it everything is compiled and built in the Docker images and runs the minimalistic test that I have. But again, due to mainly the resources and the complexity of the system, again, at the moment, it's definitely lacking in the testing part. Like for sure, this is something that needs to be improved. But again, it's a matter of resources. At the moment, things don't break much. So the priority is pushing forward instead of making sure that there'll be no bugs ever. It's just a matter of priority at the moment.
I see. And regarding Clippy, for example, do you have any special configuration, special recommendations that you might give us?
I just run Clippy at where is it? I just run it as as warning as errors, and that's it. I
Oh,
don't
so
do any kind of pedantic and all of that because mainly I want once I tried it actually gave me like a loop. I remember that a few times that I tried using like pedantic mode, it notified fix this. I fixed it the way it wanted, then it basically told me no, do it the other way, and then it was kind of like a loop, and then like okay, I think this pedantic mode is not exactly the best. So using just Clippy with warning as errors, I find that enough. Like it's powerful enough and it's great. By the way, what you can see here is actually what I mentioned previously on the targets. You see that I have like cargo target different because of all these different targets that I have and slightly different variations that just to prevent prevent all the cache invalidation. Oh, another thing that's maybe actually interesting and to me at least, I am using SQLX. So let me show you. So SQLX is not an ORM. It's all basically statically compiled. I mean, you can do dynamic stuff, but I try to use as much as I can static queries, right? So this is, for example, how it does. So this is a macro, and you need to supply it with your database URL compilation time, and it will actually check that the query is correct with your actual schema, right?
Mhm.
And this is again, this is very powerful because it's always a pain to make sure that you don't have queries that are a mismatch with the schema, right? Because they're not really in sync a lot of time, and by doing that, it actually saves a world of pain.
Wait a second. So you say this checks during the compilation time whether older SQL statements match the schema, but where is the schema?
It's extracted on its own. All you need to do is have the database. You see here, for example, why it's defined. So you need to have like the database URL envar defined before you run your compilation,
Okay.
and that's it. And it will extract the schema on its own. Expand the macros, compare them, and if you have something bad, I can actually solve it. If, for example, we'll just change it. Right? If it does, let me see. Okay. This should fail now. Here, you see?
Mm-hmm.
No column, IDX.
Nice. Okay.
And in general, I'm not a big fan of ORMs. So using although you can kind of generate your own ORM from SQLX, I like more of the functional method to use it. So the combination of the two for me makes working with the database way safer and nicer, right? Um, it's really powerful. I really highly recommend SQLX. Let's see if I have anything something interesting here that I can show. I think that's about it.
Okay. Anyone has any questions before? Seems, oops. Yeah. You're still sharing. So I can move this here. Anyone from the people who are here and listening? Any questions before we wrap up this session? No? Okay. So anything else you still would like to add before I say thank you to you?
No, I think that's fine. I talk too much.
Okay, so thank you very much again to you for this presentation. It was quite interesting. Thank you everyone who participated and everyone who is watching the video. Please like the video and follow the channel. And if you're interested to give a presentation, actually there are all kind of topics mentioned here that I would be really happy if some people gave presentations about much deeper at a much deeper level on how to use various of these technologies, various of these crates in some projects. So think about like, oh, let me teach Gabor how to use this SQLX, for example. Okay, just to pick one of them. So thank you again. What is the magic of parallelization? Oh, there are still questions.
Well, what do you mean in the parallelization? Like,
Well,
elaborate.
yeah, I guess I don't know. I'll try to guess it, but maybe he'll write the details. So one of the ideas is that Rust is a language that is relatively easy and secure to use to write code that runs in parallel, right? In Python, you can use threads, but they won't run in parallel. You have to do other techniques. In other languages, you have all the issues. Rust at compile time can check quite a few of the problems that might come up when you use parallelism. Your parallelism, what this service provides, is different from that, right?
Yeah, but internally, for example, I'm using a lot of async Rust, async.
Okay.
Like basically everything I route is async, and they're like I'll give you an example of something very minor that I do that for pricing. For example, because of the high number of nodes that I have, right? Then I need basically to manage loads on my server because effectively my own network was DDoSing me because of just the size of it, right?
Right.
And when you think about it, when you have a server, right, that is connected to your database, the inbound traffic, usually you don't control it. And then if you have, I mean, and most endpoints usually do something with the database, right? Like they check credentials, they write something, they'll do whatever, even if it's minor. The thing is that if you don't control it, then you have, issues because the database gets overwhelmed quite easily. And for example, one of the things that I've done with some async stuff and channels is instead of running every query that I get right away, um, I have, for example, channels that basically I accept requests. Like, for example, there's like an endpoint, I process it, and then I know I need to do whatever. I create a message, send it through a channel. That channel aggregates a bunch of these messages, and once it reaches whatever size, it creates a bulk query to the database. And that way, instead of, for example, sending 500 separate requests to the database, I'm able to send like one bulk request. And this is all done through, ASIC channels and a background thread that works and so on. I see that the question is actually different. You are muted. Gabor, you are muted. You're muted.
I am muted. Okay, right. So, I mean, this project collects small chunks of data and assembles it into final big data. How is this done? This was the question, but I think this what you just explained is the answer for this.
It's some of it. I mean, we collect, for example, um, it really depends on what, because there's like a lot of data that we collect. For example, we recently started using ClickHouse because Postgres was just unable to to collect the data at the size that we need. So that's part of it. And yeah, basically, like we have like all these sort of like these kind of small tricks that we use to be able to manage the capacity and collect the data, and then uh, be able to actually take it, in a manageable manner. Because once you reach, this size, although it's not even, we hope to get way bigger than that, it's still very hard. Like if you have like we have like 500,000 and more clients, it's enough for them to have, even one request per second or even less, and you're already swamped with data that you need to process.
Right. Okay. Any more questions? Last minute questions? So it doesn't say if someone is typing, right? Unless unlike other systems. So I don't know if anyone is preparing something to write. So anyway, thank you very much again for your presentation and all this discussion and for the answers. And thank you everyone who joined and everyone who's watching and liking the videos. And see you at some other meeting and some other presentation.
Thanks. Bye bye.
Thank you. Bye bye.